You know, every once in a while, a single year comes along that just completely reshuffles how we see the universe. Well, 2025, it was one of those years. Astronomers weren't just adding little footnotes to our cosmic textbooks, they were literally tearing out entire pages and starting over. I mean, think about that for a second. What if everything we've pieced together so far was just the prologue? The discoveries of 2025, they really started to feel like we were turning the page into chapter 2 for the very first time. So that's what we're going to do. We're going to dive into this new chapter. We'll look at the discoveries that are redrawing our map of the cosmos, from the universe's first moments all the way to the unbelievably powerful engines that are shaping it today. All right, first up, we're going back in time. And I mean way, way back. Thanks to some absolutely incredible new technology, we're not just looking at fuzzy pictures of the past anymore. We are staring right into the face of the cosmic dawn. This number is just mind-blowing. In March of 2025, astronomers caught the flash from a gamma-ray burst. This is one of the most powerful explosions in the universe, and it happened when the universe was only 730 million years old. This wasn't just any explosion. It was the death of one of the universe's very first massive stars. We were literally watching a ghost from the beginning of time. So how on earth do we know it's that old? Well, it all comes down to this amazing thing called redshift. See, as the universe expands, it literally stretches the light traveling through it. So the more stretched out that light is when it gets to us, the longer it's been traveling. Redshift is basically our cosmic time machine. It's how we know that gamma ray burst was a message sent when the universe was just a baby. And, okay, catching the death of a single ancient star was amazing enough. But 2025 also introduced us to a fully formed cosmic giant that, according to all our old theories, well, it just shouldn't have been there yet. So meet the Alakananda galaxy. This thing is what astronomers call a grand design spiral. It's this beautiful, mature, perfectly structured galaxy, a lot like our own Milky Way. But here's the kicker. It existed just 1.5 billion years after the Big Bang. Finding something this put together, this early on, it's like finding a fully grown oak tree in a tray of tiny seedlings. It completely forces us to rethink how quickly these massive, complex structures can actually form. So, finding these individual ancient objects is one thing, but what about the invisible structures that are actually running the show? In 2025, we got a huge clue that galaxies aren't just these lonely islands of stars. Nope, they're all connected by a hidden, cosmic web that's pulling the strings on an unimaginable scale. This discovery was a real game changer. For the longest time, the idea was pretty simple. A galaxy spins, and that's its own business, right? Maybe its close neighbors affect it a little. But then, astronomers found this, an enormous, invisible filament of matter stretching 50 million light-years, acting like a cosmic driveshaft. And get this, the galaxies along this filament, they're all spinning in sync with it. It points to a level of order and structure in the universe that we just never knew existed. Of course, the universe isn't some static museum piece. It is constantly in motion, filled with violent, beautiful, and incredibly brief events. And in 2025, we got a front row seat to some of the most amazing cosmic fireworks we've ever seen. We thought we had cosmic explosions pretty well figured out. You had your supernovas, which is one big star going boom, and you had your kilonovas, which is two superdense neutron stars crashing into each other. But then, AT2025 showed up. It was way too bright to be a kilonova, but its chemical signature just didn't look like a supernova. It had traits of both. Scientists are calling it a superkilonova candidate, and it might just be a whole new category of cosmic catastrophe. It's a total mystery. The action wasn't just in deep space either. Closer to home, 2025 was truly the year of the comet. We had a parade of them. But the real headliner, the one that got everyone excited, was 3I/Atlas. This wasn't one of ours. It was an interstellar visitor, a chunk of rock and ice from a completely different solar system, just passing through our neighborhood. It was more than just a light show. It was a chance to study the building blocks of a world that formed around another star. So, from those fleeting comets, let's turn to the most powerful, most persistent engines in the entire universe. We're talking about the fundamental forces that both annihilate matter and, from the wreckage, create entirely new worlds. We've known for a long time that supermassive black holes don't just suck things in. They also blast out these unbelievably huge jets of energy. And for decades, scientists could see these powerful X-rays shooting out in the jets, but they had no idea where exactly they were coming from. It was a huge missing piece of the black hole puzzle. Well, now we know. NASA's IXPE mission, which is a specialized X-ray telescope, was able to zoom in on the black hole in the Perseus cluster and finally pinpoint the source. It turns out the X-rays are forged right at the base of the jet in this tangled mess of super powerful magnetic fields that acts like a natural particle accelerator. After decades of searching, we finally found the engine room. But for every incredible act of cosmic destruction, there's an equally amazing act of creation. While black holes are tearing things apart, other forces are patiently building something brand new. And this is just wow. Over in the Orion Nebula, astronomers used a combined power of the JWST and ALMA telescopes to get a direct image of a planet being born. I mean, this isn't a simulation, it's not an artist's drawing. It is a real snapshot of a baby world, HOPS 315, gathering up gas and dust around its star. We are witnessing, for one of the very first times, step one in the creation of a whole new solar system. So what happens when you put all of these pieces together? Well, you get a completely new map of the universe, one that's older, way more connected, and a lot more dynamic than we ever gave it credit for. So why does all this matter? Well, this new map shows us a universe that grew up way faster than we thought possible. It's held together by this invisible cosmic skeleton that makes galaxies dance in unison. And it's a place of constant violent change, where we're discovering new kinds of cosmic explosions and literally watching new worlds being born. Every one of these discoveries in 2025 didn't just add a new fact. It fundamentally changed how we see everything. And that really leaves us here. 2025 rewrote our cosmic map, for sure. But like any good map, it doesn't just show you what you know. It shows you all the blank spaces, all the new frontiers left to explore. And maybe the biggest discovery of all is that for every single answer we find out there, we seem to uncover a dozen even bigger, even better questions.